All right. So 7E today, guys. This is properties of aX plus b, and this is going to start. It's going to start as just number crunching in formulas, and then we're going to lead up to some context of it. So for now, I don't want you to go, oh, I don't really know what I'm doing. We're just performing the formulas, and then the context of it comes later. So we'll get straight into it. What we have here is we have a linear relationship. We have variable x, which has a mean of 3.6 and a standard deviation of 1.2. That's how the variable x, the random variable, is distributed. And that's what this symbol means. It just means variable x is distributed with a mean of 3.6 and a standard deviation of 1.2. Now, we have y is another random variable that has a linear relationship with x. So x is a random variable with these properties. Y is a random variable that is related to x with these properties. And so that means we can know what's the expected value of y, what's the variance of y, and what's the standard deviation of y using these formulas. I'll also point out that remember the mean and the e of x are the same thing. They mean the same thing. Oh, do you know you're at the presentation?
Yeah, Mr. Denise told me to come up here.
Oh, how good. All right. Cool. All right. So we have, let's get straight into it. We've got these properties. Find e of y. All right, find the expected value of y. So we're going to use this formula here. E of y is equal to e of ax plus b, which is 2x take 3. Okay, it's the expected value of 2 lots of x take away 3. And that's equal to 2 times the x value take away 3. All right, 2 times e of x take away 3. Let me write that like this. 2e of x, take away 3. And our e of x and mean are the same thing. So it's 2 times 3.6, take away 3, 7.2, take away 3, gives us 4.2. So the mean of e of y is 4.2. All right, all we're doing, the coefficient of x times the expected value of x. All right, so 2 times 3.6, and then plus b. What's our value of b over here? Take away 3, taking away the 3, gives us the 4.2. Okay, find the standard deviation of y. So now we're coming down to this one. The standard deviation of y is equal to the standard deviation of 2x take 3, which is the modulus of a. Now, when you see those two lines, expect kids will be familiar with it. And if we have the modulus of a, that just means the size of it. So all it means is the positive number a. All right? So if a is 2, we're finding the modulus of 2, it's 2. If we're finding the modulus of minus 2, it's 2. All you do is make it positive. That's what modulus means. So we're going to have the modulus of the coefficient here, the modulus of 2, times the standard deviation of x. And the standard deviation of x, I'll write it like this first. 2 equals 2, and then the standard deviation of x is 1.2. Gives us 2.4. All right, and then lastly, find the variance of y. So the variance of y, we'll use this one here, is a squared times the variance of x. Now, we don't have the variance of x explicitly, all right? We've got the standard deviation, and what we should remember is the variance is the standard deviation squared. Okay, that's the link that we need to make. So the variance of x, that part there is going to be the standard deviation squared. And our value of a is the coefficient of the x term. That's 2. So we have 2 squared times 1.2 squared. We'll evaluate that quickly. 5.76. Okay, so that's the first part that we're doing, okay? It's just a bit of number crunching, just finding expected value of y given it's a linear relationship to x. Just one thing I will point out that pops up time and time again, right, is if we have y equals x on 2, how should we understand that? We should always think about it as that's half of x. Always pull that out front as a number, so that you can see it's y equals some number times x. Okay, we'll go through the second example now as well, which is a application of what we're up to here. So, we have Sherlock is a detective who makes $10,000 a month, plus $2,000 for each crime that he solved. Sherlock knows the number of crimes solved each month, X, will follow the discrete probability distribution below. Alright, so we've got the number of crimes. He could solve 0 crimes, 1 crime, 2 crimes, 3 crimes, or 4 crimes. And the probabilities here are 0.1, K, 0.36, 0.2, and 0.1. Part A says find the value of K. Right, we know all probabilities have to add to 1, so what have we got? We've got 0.2, 0.4, 0.76. This K has to be 0.2. Find E of X and explain its meaning. Alright, so we're finding E of X of this distribution here. And we've been doing E of X for a bit now, and it's sort of, we're at that stage where it's like, it's almost just as fast to do it manually as it is to type all that into your calculator. We'll just evaluate it here. We've got each event times the probability. And we'll evaluate it. And again, you can type that into your calculator. That will have here 0.24, it's 0.72, what's 0.6, what's 0.4. That's 1, 1.72, 1.96. All right, so that's E of X. All right, so we've evaluated it, but it also says find E of X and explain its meaning. Okay, so what's the context here? X is the events, all right? So this is 0 crimes per month, 1 crime per month, 2 crimes per month, 3 crimes, 4. And then these are the probabilities. What we've calculated here is the expected value, the mean of the distribution. This means, on average, we expect him to solve 1.96 cases per month. So let's state that. On average, Sherlock solves 1.96 cases per month. Okay, so that's the random variable X, and here's the point of what we're performing is we're making a relationship between X and Y. Let Y be the amount of money Sherlock earns per month. Express Y in terms of X. So we're told Sherlock earns $10,000. So let's say Y equals, let Y be the amount of money he makes. $10,000 plus $2,000 for every case. So it's 10,000 plus 2,000x, or we can state it with the x term first, it doesn't really matter. $2,000 per case plus a side amount of 10 grand. Okay, now find E of Y and explain its meaning. Well, Y is a direct relationship with X, right? So if this is Y, then the expected value of Y is going to be A times the expected value of X plus B. So let's write that out. The expected value of Y, now is this part C or D? This is part D. The expected value of Y is A, the coefficient of the X, multiplied by E of X plus B. And now E of X, we evaluated before, 1.96. 2,000 times 1.96. What's that? 3.8. 3.92. All right, find E of y. Here's E of y. Describe its meaning. All right, y, the variable y is the amount of money Sherlock earns per month. This is the expected value of y. So on average, we expect him to earn $13,920 a month. Okay, so the first part of this chapter, we'll start off with just some formulas, number crunching, and then the second part you start to get into some context like this that involve a relationship between x and y. So we'll give that a go. I'll float around, see how everybody's doing. That's the plan today.